Hey, it's Finn, and today we'll be going over how to upload a server build from Unity to GameLift and deploy it to a managed EC2 fleet. First things first, some prerequisites. You'll need the Unity GameLift plugin, which you can get from the link in the description. It will take you to this page. You click on the C# option, and then download the latest version of the plugin. So for this demo, we'll be using version 5.2. You'll also need the AWS CLI set up on your machine for your account to be able to upload a build. There'll be a link in the description to the documentation explaining how to set it up. From here, you need to unzip the file you downloaded. In there, you'll find the server SDK folder. To get the plugin working, you need to have some third-party DLLs installed. You can download and install the DLLs directly, but the easier way to manage them is to add the NuGet scoped registry to your project. To do that, you need to do the following. Open your project in Unity. From your project, click Edit, then Project Settings. From there, choose the Package Manager option. Under the Scoped Registries section, click the plus button. Then add the following info, which will also be in the description. Name, Unity NuGet. The URL is https://unity-nuget-registry.azurewebsites.net, and the scope is org.nuget. Then click Apply, and Unity will fetch the registry for you. Now go to the Window option and open Package Manager. From there, click the plus button. Select Add Package from Tarball, and choose the GameLift Server tar from the unzipped plugin folder, then click Open. Wait for Unity to load the SDK into your project. To implement the server, we need to add some code that initializes the SDK and sets up the functionality for it. Within my project, I'm going to create a scripts folder, and in there, create a server script, which I'll then attach to an empty game object. Open up your script in your IDE of choice. I've removed the update function from the mono behavior, and I'm implementing the rest of this in the start function. For simplicity's sake, I've hard-coded the port the server will use. Then, we call the init SDK function from GameLift and check the result of it. We'll add some logging for if it's negative. If it's a success, we create a new process parameters variable, which gets used when we communicate that the server is ready to host game sessions. You'll want to implement the following. The game session callback is where you want to process the game session object received from GameLift and take any actions based on it, for example, setting up any variables. When your server is ready to receive incoming player connections, you want to invoke activate game session. The update game session callback can be useful if integrating features such as flex match backfilling, allowing you to examine newly provided matchmaker data and appropriately handle new incoming players. The onProcess terminate callback gets invoked whenever an instance is about to shut down. It's useful for the server to save its states and communicate with any other services before it gets ended. For this tutorial though, we'll just call the process ending function from the server API. The onHealthCheck callback gets invoked every 60 seconds or so. It's ideal for you to check the health of any dependencies you have in your project and return a true if they're healthy and a false otherwise. For this tutorial, we'll set it to always respond with true, and then, if the server doesn't respond, GameLift defaults to false. You'll also want to include the port the server uses. Here we use the variable I declared earlier. The log parameters are a list of files to be uploaded whenever a game session ends. After these have been declared, you want to call the process ready function, passing these parameters into it, in order to tell GameLift that the server is ready to receive incoming game sessions. I've also added some logging to confirm whether it succeeded or failed. It's also good practice to reset the connection to the GameLift agent locally whenever the application is closed. You can do this by calling the destroy function in the server API. After you've added all your code in, you're ready to build the server. First, it's important to make sure your project name doesn't have any spaces in. This can be changed in Edit, Project Settings, Player, Product Name. In your project, go to File, Build Settings, then click on the Dedicated Server option. From here, Set your target server platform and architecture accordingly. In this tutorial, we'll be creating a Windows build. Click Build, then create a new folder in your chosen directory. Unity will then build your project to that folder. Now it's time to upload your build to AWS. We'll be using the AWS CLI tool to upload our build. All we need to do is send an upload build command with parameters for the operating system, in this case Windows 2016, the server SDK version 5.2.0, the build root, which is where your build directory is, the name you want to give your build in AWS, and the region you want to upload your build to. If you're deploying your game in multiple regions, you need to create a build for each region. The console will update you on its progress, and on its success will return a build ID. You can view this build in the AWS GameLift console. Awesome, now we can create a fleet. We will be making a managed EC2 fleet for this tutorial. Open up your GameLift console in AWS. Click on the Fleets option under Managed EC2, and then click Create Managed EC2 Fleet. From there, add all the relevant details for your fleet. Choose Build for the binary type, and select the build you uploaded from the build dropdown. Add any IAM roles, metric groups, or tags you may need, then click Next. On this page, configure your instance types to suit your needs. As this is a demo, we'll select on-demand fleets with the smallest instance type, then click Next. Next, you should set up the launch path in the runtime configuration. It's where the server exe file is within the build folder we uploaded earlier. So for this example, it'll be GameLiftUnitySample.exe. Decide how many game sessions you want to be active on each instance and tweak any port or resource settings, then click Next. After this, review all your options, and then when you're happy with them, click Submit at the bottom of the page. From there, GameLift will spin up a fleet for you. This may take some time depending on the size of your project. And there you have it. You've successfully uploaded a server build to AWS and run it on a managed EC2 fleet.